Hello friends, welcome to Electrical and Instrumentation Engineering YouTube channel. In this channel, we will learn about the electrical and instrumentation engineering informative content that is in three languages: English, Hindi and Kannada. Please subscribe our channel to get the notification of my videos. Let's move into the topic. So in the previous section of the video, we have learned that three parts of the PLC programming. So what is in the first part, I have explained you about the configuration of PLC hardware, and in the part number 2, I have explained you about the control wiring diagram of PLC hardware, and in part 3, wiring diagram of PLC modules to field devices that I have explained. If you want to watch those videos, the links has been shared in the description box. Please click on the description box so that you will get the video notification. Let's move into the today's topic, that is simulation of PLC program with the field devices. How PLC program is used to simulate with the PLC field devices, let's understand. In the last video, we have seen the digital input and digital output models. Regarding that same basic PLC programming, using basic PLC programming, that is the ladder logic, so we will understand how field devices communication with the input and output models. See here, I will draw the ladder logic here for your reference. This is the line which is called as a power line in the ladder logic. It consists of a power, that is a soft power, the soft copy, and it consists of a soft power. For your reference only, I am explaining you. Okay, so what happened in the next, just a minute, what happened? So after this, see this. See, I have drawn the power line from here and added a NO contact. In the NO contact, I have assigned a PLC address for the digital input, that is called I001, percentage I00, which is here. The percentage I001 is here, which is assigned as an input address. This input address receives power supply from this push button. When the user presses this push button, the power will transmit from 110 volt AC through fuse to NO contact, and when this NO contact gets closed, and when the push button is pressed, then the power will transfer from this power will flow from this to a fuse contact, and fuse contact to it will operate the relay, because relay already consists of a 0 volt AC. So when the relay will act, then 24 volt DC is commonly applied to the relay NONC contact. From common, this supply will move to the channel number 1 of the digital input model. When this supply will move to channel number of digital input model, this will become NC contact. So the power will flow from this contact to this contact. This is called a NO contact. After the energizing of this relay, this will become NC contact, and power will move from here from there. So next, what will happen? Let's understand after this completion of this. So next, output address we have added. See what happened. This is the output address. This is assigned to Q001. This is the PLC assigned address for digital output, and this symbol represents the digital output. This symbol represents the digital output. So digital output model also happened in the previous slide. Here what happened? When user press the push button, the power, we understood that power will flow from this end. Power will flow from this end to and energize this relay, and the 24 volt DC will flow from common to NC contactor to channel number 1. So channel number 1 will activate, and the power will flow from this here to Q001. When the Q001 acts, this will get energized, this will get acted. So the when where is Q001 hardware? Here Q001. This is the channel number of Q001. So Q001 will flow give 24 volt DC to the relay directly, because we have applied 24 volt DC to the model, and the Q001 will be 24 volt DC, and the relay consists already 0 volt DC. When 24 volt DC applied to this relay will get active, and in common contact we have given 110 volt AC here. So through common contact will become common, and NO will become NC after energizing. So power supply of 110 volt AC is flow to the fuse terminal, and through fuse terminal it will act the indication lamp, because indication lamp is already receiving the 0 volt AC. This is the working principle of the program, how the program will act. So according to this, what we understood that how PLC models and program will act accordingly, because when using the push button and indication lamp, this is for your kind information, and it is a very basic PLC program. If you want any advanced PLC program, or if you want to learn something more, just comment on the comment box. In the next slide, I am going to explain you regarding the. Now we will learn the analog input model. How analog input model and analog output model will communicate using the ladder logic. See here, this is the analog input model. and this is the analog output model. Regarding the analog input model, analog output model, field devices communication, I have explained you in the previous video, which is in the link description box. Please see the video for the detailed information. Let's understand how ladder logic is communicated with the field communication using the analog input model. See, already we understand that this is a power line, and we will extend the power line to here for making a ladder logic. So after the extending the line, let's see what to do. We will add one instruction here. So this instruction represents DIV, means the division instruction, mean the one is receiving the value from the pressure transmitter in the sense of counts, and the two which is we want to go into divide. If suppose example I will tell you, if one is receiving 100, and if we want to divide using the 2, if 2 is we set it as a set point as a 5, then 3 will be the 20. This is the output. This one is represents 100, and 2 represents 5, and 3 represents 20. This is the for the example only I am explaining you. The detail I will explain you in here. See what happened when we apply the pressure. When we apply the pressure to the pressure transmitter, the pressure transmitter will give output in the sense of 20 milliamps. That is here. The pressure transmitter is receiving 24 volt DC from the model, analog input model, through fuse terminal, and based on the pressure, if the pressure transmitter range is 0 to 6 kg, and pressure transmitter receiving 6 kg pressure to transmitter, then it will give 24 volt DC, for 20 milliamps from the pressure transmitter to channel number 9. The channel number 9 is addressed as a AI001, that is analog input 001, which is here in the channel number 1 of the division instruction. So when the channel number 1 receiving 20 milliamp, it will read as a 32,767 counts in the PLC, because here in the table I have explained you the 20 milliamps represent, if his PLC is receiving 20 milliamp, then the counts in the PLC will be 32,767. If the 16 milliamps PLC is receiving, then the counts will be varied to 24,575. If 12 milliamps, then 16,383, 8 milliamps 8,191, and 4 milliamps and 0. If it is in between the 16 milliamps, proportionally the counts will be the change according to the PLC. So let's understand for your reference. In the point number 1 of the division instruction, it is receiving a 20 milliamps for assumption, and it will give you 32,767 output. So we are dividing 32,767 with the 5,461 in the point number 2. So division of 32,767 by 5,461, we will receive the 6 as an output, that is stored in the registered value of the PLC. So this registered value can be sent to the SCADA or any other output devices to show the signal the pressure transmitter is receiving the 6 kg pressure of water or any air or any parameter which is you are going to apply. The same concept will be applied to the output model. See what happened in the output model. This is the ladder logic program, and I have added a line, extended the line, and I have added an instruction. This instruction we refer to as multiplication. This instruction we have multiplication. So if suppose the address number 1 is receiving 100 and 1, and the 2 is we have set it as a 5, and the result will be the 500. So 3 will be the 500. This is for the example I am explaining you. 100 is the 1, 2 is the 5, and the 3 is the 500. This is the for example only I am telling you. Let's understand the practical example how it works. So here, so R002 is the registered value. So if the user set the set point as 100% to run the, suppose we have a motor RPM, we want to check the motor RPM and to display the in the display value. If the user set the 100% in as R002, then we will multiply this 100 with the 327.67. So multiplying 100 with the 327.67, we will get the value of 32,767, which is in the AQ0001. When AQ0001 gets 32,767, then it will give 20 milliamp supply from channel number 1 of the analog output model to through fuse device to the extra to the indicator. So when the indicator receives the 20 milliamps from the PLC and it will return to the PLC, it will indicate 14,137 RPM. You can set the zero span and the maximum span in the indicator. When the maximum span set as a 1437 for 20 milliamp, and it will flow, it will read as a 1437. Here, see, look into the table which is explained for your kind reference. So after this, after this slide, let's understand. Thank you for watching this video. In my next two videos, we will learn all the parts in Hindi and Kannada language. So configuration of PLC hardware, control wiring diagram of PLC module to field devices, and simulation of PLC program. So we will learn in Hindi and Kannada language. After completing this Hindi and Kannada language, I will give a competition to you all the competitors who want to join. So in the YouTube video, I will explain you the some questions about the all the parts. So you have to answer for all the parts, which will get you expertise in this PLC field, and you will understand it will helpful for interview and your job working area or anywhere. If you like this video, please like, comment and share with the required one, and please subscribe our channel to get the notification of my next video.